Please take a moment to either open your textbook or ebook to example 2.4 on page 42. The example lays out a scenario where an instructor has given an exam to n equals 25 students, and the task is to organize the scores into a frequency distribution table. However, upon examination of that data set, you will see that the lowest score is x equals 53, and the highest score is x equals 94. So if you were to organize those scores into a frequency distribution table from largest to smallest score, you would have 42 rows. When you have a data set where the distance between the largest score and the smallest score is more than about 15 points, you create a grouped frequency distribution table. The 4 bullets listed on the slide provide a flexible structure to use to build a grouped frequency distribution table. Take a look at the grouped frequency distribution table on the next slide. It has been created using these rules and is based on the data from example 2.4. So in examining the grouped frequency distribution table and in counting the rows, you learn that there are 9 rows of data. This is in keeping with the rules listed on the previous slide because what you're going for is about 10 rows or intervals. Could be 9, could be 11, could be slightly more, but you certainly want to keep it at 15 or less rows. The width of the interval should be a simple number, and the width in this example is 5. 50, 51, 52, 53, 54. Count how many numbers are in that interval grouping. That's how you determine the width. The next bullet says that the bottom score of the interval, each interval, should be a multiple of the width. What this means is that if you examine each interval, you will see that 5, the interval width, can be divided into 50, 55, 60, 65, 70, and so forth. And finally, you can see that each interval grouping is the same width, all groups of 5. So you wouldn't want to have your first interval grouping consisting of 4 numbers, then the next one 5, then back to 4, and so forth. Stay consistent with your format. Also remember that our lowest score value in the data set was 53. You don't have to start your lowest interval with that number. Just create an interval in which that number is included. Finally, notice that the center column shows the real limits of the intervals. Remember that a real limit of a number is a half measure below it and a half measure above it. So the real limits shown there reflect a half measure below the lower interval number and a half measure above the highest interval number. There are disadvantages associated with a grouped frequency distribution table. As is summarized on the slide, you don't know what the specific scores are within an interval. You just know how many scores fall within that interval, and the wider the interval, the more information is lost.